This video presents the intraoperative assessment of bowel perfusion using fluorescence-based enhanced reality. An ischemic segment was created in a loop of small bowel and 0.5 milligrams per kilogram of indocyanine green was injected 2 hours later. The D-Light-P laparoscope was switched to near-infrared mode to capture the fluorescence signal. The enhanced reality perfusion software was used to analyze the fluorescence signal in real time in order to build a perfusion cartography based on fluorescence time to peak. The software stores the information related to fluorescence intensity, which corresponds to the y-axis on the graph, and its evolution over time, which corresponds to the x-axis. This allows to navigate directly on the laparoscopic video images of the bowel to calculate the local perfusion pixel by pixel. The perfusion map can be superimposed on the real images as a color code, as in the example displayed, or as a line showing the perfusion levels. In this experimental setting, the aim was to display various levels of perfusion in the same loop of small bowel. To do this, regions of interest were placed in the hyperperfused area with slower fluorescence time to peak of the perfusion cartography, which corresponds to the red box, and in 2 perfused areas with fast time to peak at both sides, which corresponds to the green boxes. The software rapidly calculates the perfusion level to display on the bowel, ranging from 1 to 99% as compared to the perfused area and the ischemic area. In this specific case, the animal was assigned to have a resection and anastomosis at 75% of maximal perfusion. First, the 25% level was identified by FLIR and marked with a surgical clip at both sides. The 75% of perfusion was subsequently identified and marked with a surgical marker at both sides. This analysis allowed to identify the following regions of interest. Region of interest 1, the ischemic area. Regions of interest 2A and 2B, areas where perfusion was dropping by 25% and 75%. Regions of interest 3A and 3B, reference areas where perfusion was maximal.